Hey there everyone, this is Tuesday, the 26th of January. We're looking at our Do First from the Desmos today. So if you see here, we're talking about the Math Club. This problem we're going to work through a few different ways. So just start here by thinking about this. You know you have $108 earned through $5 bills and $1 bills. So what are the possible ways that you could have $5 bills and $1 bills to get to 108. All right, so think about that question. Take a moment, hit pause, and type in some of your ideas here. Well, hopefully you took a look here. But what I would do is I'd say, well, if I have $5 bills, let's make an actual 5, and I have $1 bills, what are some combinations? Well, I could have 0 $5 bills, and then I could have 108 $1 bills, because together that equals $108, right? 108 $1 bills is $108. If I had 10 $5 bills, well, how much money is that? That's 50 bucks, right? Okay. So then I need how much more to get to 108? 108 plus minus 50 is 58. So I would need 58 $1 bills. Do you kind of see that math? All right. 10 $5 bills is $50, and then 58 $1 bills, that gets me to $108. Well, I could also have 20 $5 bills. 20 times 5 is $100. So then I only need 8 $1 bills. All right, so we're just trying to get your brain moving. Think about that. 5 plus $5 and $1 together. And so if you look at the next screen, it's a Desmos graph here, and what you can see is there's some other choices here for you, right? We have 19 and 13, where this is $5 bills, this is $1 bill, and all these combinations go in here. So go ahead and put your values in there. We said 0, 108, and see where that shows up right here. We also said we could have 10, and then that would be 58. And you see where that showed up right here, 10 and 58. We also said 20 and 8. And that shows up down here. Well, so all of those look like they're forming a what? Right? They're forming a line. And so we could keep putting those values in there, and maybe you found a few more values to plug in and see how they work. Then when you do that, right, think about, is there an equation that could model this, right? Well, we said 0 was 108. And so that's our y-intercept, right? 108 is our y-intercept. The other way we could think about it is, if I'm going to go down $5 for every, or down 5 $1 bills for every one $5 bill. So if you can't see it in this idea, let's put in a couple more. So I'm going to just delete these so that you can see what our change is, right? Remember when we were writing equations before, we need to find what our slope or our change was. So if I go up one $5 bill, I'm going to go down 5 $1 bills. So that's going to be 103. And if that math doesn't make sense to you, think of this is, 1 times 5 plus 1 times 103 to get to 108. If I go 2 $5 bills, now that's $10. I'm going to go down 5 more $1 bill. And we keep going, and you can see how my line's going from here to here to here, right? If I had 3 $5 bills, now I go down 5 more to 93. If I had 4 $5 bills, I go down 5 more to 90 or 88. And you can see we keep that pattern going. So our vertical change is 5, our horizontal change is 1. So it's going, delta y is going down 5, right? And delta x is going 1. So we would have the equation y equals 5 over 1 x plus, where does it start? 108. Sorry, It's going down 5, right? So that's a negative 5 over 1. So that's one way to think about it. And see how it follows our line? There's a lot of different ways to write this equation. If you look down at the bottom of the screen, we can eliminate that 5 over 1, right? Because 5 divided by 1 is just 5. Right? And we can think about another way to write this equation would be, I know I need to get to $108. So for every $5 bill, we say 5 times the number in X plus 1 times the number of Y's, which is our $1 bill, has to equal $108. And if you notice, I'm going to change this color just so you can see it. If I change that color to, say, green, notice it's the exact same line. Okay, that blue line and the green line are the same. Right? So that's two forms of the same equation. So take a moment to think through that. It's pretty powerful stuff. All right. So once you figure that out, work your way through the rest of these announcements. Yesterday we talked about a new grading policy, so go back and see that. And today we're going to focus on turning words into equations and then solving them with substitution. And so we have a lot of work to get through. I'm going to do at least 2 videos today. Maybe we'll get to 3, but I only have 9 minutes left in this first video. So by the end of this section, you should be able to say, how can I write equations from word problems? And then how can I solve those equations algebraically? So here we are back at the Math Club riddle. And now we have one more piece of information. We know the bills have a total, or there's a total of 48 bills. So we still have that idea that it's going to be 5 times our X value plus 1 times our Y value to get $108. That's the equation we just talked about. And then the next equation, we need to add up to 48 bills. So we're still going to use X for our $5 bill value or $5 bill number plus Y for our $1 bill value. And so we can define these values by saying let X equal the number of $5, I need to be able to spell, $5 bills. We're going to let Y then be the number of $1 bills. We have 2 equations. Guess what we can do with 2 equations? We can solve them using substitution. So go ahead, pause, set this up in your notebook, and then let's go ahead and work on this. So if you want to work through this, you can head to slide 16 to see if your answer is correct, or else let me walk through this just a little bit more for you. So we said the number of $5 bills plus the number of $1 bills needs to equal 48 bills. And then the money from the $5 bills and the money from the $1 bills has to equal $108 total. So we are going to let these be our variables, X and Y. And so when we erase this, we get 2 equations. X plus Y is 48, and 5X plus 1Y is 108. Now, to solve using substitution, let's take that top equation, and we're going to take X plus Y equals 48, and we're going to turn it into X equals 48 minus Y. How do we do that? Well, we subtract Y from both sides, and we end up with a value for X. And so look at what we can do here. All right, we take our second equation, 5X plus 1Y, and we plug in for X. 5 times 48 minus Y plus 1Y. And then we just need to do the algebra. And you can walk your way through here. We distribute the 5, so 5 times 48, and 5 times negative y gives us 240 minus 5y plus 1y. We subtract 240 from both sides after we combine negative 5y and 1y to get negative 4y. When we subtract both sides by 240, we get negative 132 on the right, negative 4y on the left. So then we divide negative 4, divide both sides by negative 4, and we end up with y is 33. Well, when we know y is 33, go back to your first equation right here, x plus y, and plug in 33 for y, subtract it from both sides, and you find out x is 15. All right, and so this example is written for you on slide 16. Go ahead and take a look at that. What I want to show you too, go ahead and go back to slide 14, where we have these two equations. All right, and so what you can see on here is that first equation that we typed in the do first, 5x plus 1y equals 108. But then let's type in that second equation that we found. We said x plus y has to equal 48. And if you see these two equations on the same graph, look at what happens. They intersect at the solution, 1533. Well, what does 1533 stand for? 15 $5 bills, 33 $1 bills. Do you see the layers that are happening here and how many of these things intertwine? All right, it's going to take practice. It's going to take a lot of work, but we're going to try this out as much as we can. All right, so all that information's there for you. We're going to go ahead and work on slide 17 together. And it says you sell tickets for admission to your school play and collect a total of $104. So we're starting to think through these pieces. Admission prices are $6 for adults, $4 for children, and you sold 21 tickets. How many adult tickets and how many children's tickets did you sell? And then we say, let's start by guessing. I'm going to guess? Well, yeah, sometimes we guess, right? Sometimes, and I like to use this guessing idea to help understand what the equation is talking about. And so let's guess a number of adult tickets. Let's say I think there's going to be 5 adults. Okay. Well, then how would I know how many children there are? If there's 5 adults, can I figure out how many children there are? Well, yeah, because we need these to add up to 21. So 5 and what is 21? 5 and, well, I just need to subtract. 21 minus 5 is 16. So 5 plus 16 could be 21. Yeah, so 5 adults, 16 children could be 21. Well, how much would that cost then? Is that the right answer? Is that $104 worth of tickets? Well, I could say, well, if I had 5 adults, how much is each adult's ticket? Oh, it's $6. So I would do 5 times $6 plus 16 times, $4 per kid. Does that equal $104? So let's do the math. And again, I'm just guessing. I guessed 5 adults. So 5 times 6 is $30. 16 times 4, well, I have to do that in my head. 10 times 4 is 40. 6 times 4 is 24. So 40 and 24 is $64. Does that equal 104? So 30 and 64, nope, that equals 94. All right, so that is not the right guess. Okay, it's not 5 and 16. I'm too low, so I need to make more money. So I probably more adults. All right, and you can keep guessing and checking and guessing and checking. Only with a minute left in this video, we'll continue these next slides in part 2. But think about this. If I said let's let the adult number of tickets be X and the children's tickets be Y, I know I have X plus Y has to equal 21. And then I can say, well, 5 times, or sorry, not 5, it's $6 per adult, right? So 6 times X plus 4 times Y has to equal 104. And now go ahead and try to walk through solving this system of equations. Go ahead and check the next slides for your answers. And if you want to keep this going, check out part 2 of this video.